Saxon Algebra 1, Lesson 87. Greetings, students. I just recorded a couple lessons for Algebra 1 half for Caleb, and I made ridiculous, silly mistakes right and left. So let's hope I am on point for you guys. Lesson 87 has two topics. The first one is the meaty one, and it's called More on Systems of Equations. This could be the name of our entire class, couldn't it? We have done systems of equations in 16 different ways. But here comes more, right? John is giving us 4 monstrous, crazy-looking equations, and he's asking us to solve. Here they come. Ready? Here comes the first one. John writes them all across the page. I'm going to write them down because it's too much. Again, we have these subscripted variables. We don't know what they mean. We don't know why you have them. All we know is there they are. The first one has lots of letters. The second one is simple. Whoops. The third one is simple. And the fourth one isn't horrible. Okay? So we got these 4 equations. They all have these subscripts. And it says W. This is example 87.1. Okay, so we're supposed to solve for these two guys down here. All right, now we've seen something like this before. We know that this is the base equation because it has all the variables in it, and we know we're going to plug this one into that space, we're going to plug that one into that space. This one we're going to have to change in order to get it to plug in. We can either subtract the TW, that's usually what I do. I usually leave the first one here, and I subtract the second one. But you could do it either way. So here we're going to get this TE equals 9 minus TW. One time on a math test when I was probably in like 8th grade, I simplified this by making it TW minus 9. I reversed the order. It's 9 minus TW. I just put the minus sign in front of this. I did it like this, which is clearly wrong. But I decided I liked the way that looked better, and I thought I could do it. I couldn't. I got the problem wrong. I've never forgotten. It's a little weird that I remember math problems from when I was 12 years old and things I did wrong. But anyway, I did. So now we've got things we can plug in. We fixed this one. So now I'm going to rewrite this in buckets. And let's plug in. RE equals 200. TE equals this. RW is 250, and TW, we don't know, we just put that in. And now we double check and see, oh yeah, our variables match, so we're good. This we're going to have to distribute. This becomes 1,800 minus 200 TWs equals 250 TWs. Okay, I like it. For some reason, my brain always thinks at this point, let's hit it with an algebra stick. I don't know why that is the phrase that jumps in my head, but it does. We're going to swim the TWs this way, leave the plain number here, goodbye. 1,800 equals 450 TWs. So now we're dividing both sides by 450. Here's the way my brain sees this. I know that 45 plus 45 equals 90. And so that tells me that 450 goes into this 4 times, right? Because 900 goes in here twice. And there's 2 450s in each 900. So that tells me that TW equals 4. You can do that by long division if you want to double check my thinking. But I'm pretty sure I'm right. TW equals 4, and then I go back up here to this equation is the one I want to look at now. This has to add up till 9, 2, 9. So this must be 5. Here's my answer. Yay, I'm right. Okay. It would have worked out just fine if we would have rearranged this equation the other way. We just would have solved for the other equation first. Okay, yay us, we did it. We get to do one more. Aren't we lucky? This is a privilege, you guys. We get to do another one. Example 87.2. Given, okay, here we go again. This time we have subscripted numbers. That's a little different. But I like it because we can say R2, T2. And then we have R1 equals 30, R2 equals 40, and then we find that T1 plus T2 equals 10. And again, we're supposed to find these two. Last time I said generally I like to leave the first one here and subtract the second one. Let's just do it the other way around for fun. So I'm going to subtract T1 from both sides and get T2 equals 10 minus T1. All right, so here's our base equation, and then here are the three values we can plug in. Make myself some buckets. They're not on the line. That's a shame. Okay, R1 is 30. T1, we don't have a value for that, so I'll just put in T1. R2 is 40. And T2 is this crazy thing, 10 minus T1. Okay? Before, notice we distributed on the first side, now we're distributing on the second side. It doesn't matter, it's all good. So, 30 times T1 equals 400 minus 40 T1. Yes? I want to make sure I've got all my numbers right. Oh, this is what's wrong. Okay, my bad. See, I'm doing it again, you guys. I'm having a crazy day. R1 times T1 plus R2 T2 equals 360. I used the wrong base equation. I used the same format from last time. So let me do this over, setting it up. This rearrangement is all fine, just the way it is. I just used the wrong base equation. Oh my gosh. I need to remember what I had for breakfast and never have it again, because it made me crazy. Okay, this is much better. Now we can plug things in. R1 is 30. T1 we don't have a value for. R2 is 40. T2 is this thing, 10 minus T1. 360 is over there. All right, now this is the one we distribute. So 30 times T1 plus 400 minus 40 T1 equals 360. Oh, I feel so much better, don't you? You're like, but we're not the ones who screwed it up. Okay, let's live dangerously in minus land. We'll swim that 400 and then we'll combine, we'll add those like terms all in one big step. 30 minus 40 means we have negative 10 T1 left. This is gone, and this equals negative 40. Oh, I like it. Negative 10, that cancels. The minus signs cancel. 40 over 10 simplifies, so we find that T1 equals 4. Yay, at least I got the right answer, you guys. I found my mistake. And the way I found my mistake, when I got to this point, my brain quickly jumped ahead, and I realized that I was going to have 70 and 400, and 70 doesn't go into 400 evenly, and I knew John would not give me an ugly fraction. So that's how I caught my mistake before I got to the end, and I looked back at this, when I realized this math was not going to turn out pretty, I looked back at this in the book, and I said, oh my gosh, I made this up, I made that up, because this was the way it was in the last problem, but this problem, the base equation is different. So, mistakes happen, it's just a question of having a process where you can catch your mistakes. All right, we've solved for T1, but we have to find T2 also. They add up to 10, so that tells me that T2 must equal 6, and that's the right number. Yay! I'm very thankful that I got to the end of that problem. All right, so that's lesson 87, part A. Part B is something fun and easy that shows up on standardized tests fairly often because everyone in the world forgets it. It's called a vertical line test for functions. Now, we've done the thing just in recent episodes where we test for functions by comparing, right? We did this thing, and we know that everybody on this side has to have one and only one partner on that side, right? We know how to do that. And then we did the thing where we have like pairs of points in parentheses, and we would know that this one's not a function because 2 turned up with 1 and then it turned up with 17, right? So this would not be a function, and let's make this one so it's not a function. Sometimes this value goes here, sometimes it goes there. No, that won't work, okay? So those are tests for functions, okay? What we're learning, that was one test. This is another test. Third test that we're going to learn is when we have a picture of a function. And John gives us 2 pictures in this lesson. And the first one, and these are functions that we haven't learned a lot about yet. Okay? This is called a sine wave or a cosine wave. We don't know much about that. We don't know how to graph it. We don't know what it looks like. This is just a confusing thing. And then the other one is a circle. We've dabbled only in graphing circles. We don't know how to graph those things. But guess what? That's why these problems show up on standardized tests, is because everybody thinks they're harder than they are. The truth is that to do a vertical line test, all you do, a vertical line test, is you literally draw vertical lines. Oh, I hate writing these out. Let me write it and then I'll explain it by doing it. Okay, vertical line test. That seems obvious. What we're doing is we're drawing vertical lines and noticing how and where they pass through our function, right? This is the function. Okay, this first line, it only hit the function there. The second line, it only hit it there. The third line only hit it there. The fourth line only hit it there. So I just chose those places at random, but so far this is passing my vertical line test, which says that any line I can draw cuts through the function only once, right? So this intersected it. Intersect is probably a better math word, okay? So this one looks to be a function. Yes, it's a function. This one gives us a different problem, because I can see right away, look, I could draw a line right there, and it's going to pass through twice. So this is not a function. Okay? And you have to kind of use a little common sense on this. Like, I can see in this one, I could draw this curve over and over, but my line would only pass through it once. And let me just remind you, it's vertical lines only, because if you went horizontally, you'd have drama. But it's only vertical lines, okay? So by drawing vertical lines, if those lines hit our function, intersect our function only at one point per line, then it's a function. If it intersects twice, no bueno. All right? That is the vertical line test. It is easy, it is simple, it is visual, it involves no calculation whatsoever. And that's why standard test people use it, because it's super easy for people who know it, but for people who don't, they're lost. Let me just show you the practice ones. You can just imagine yourself drawing a line. Yeah, that would intersect. And we could hit it 3 times here, couldn't we? So this is not a function. This one, well, it's never going to cross over more than once. So this one, yes, a function. And here, again, no, it's not a function because it hits twice. Now you can argue, well, what if I drew the line over here? It might hit only, not at all. So it touched that point perfectly, it would just be once. It's not if you can draw any line that doesn't pass it, it's if you can draw any line that does intersect it more than once, okay? So if you can draw even one line that hits that function in more than one place, then the function fails the test, all right? So that is now our third method of testing whether a pattern of numbers is a function or not. We have the diagram test, we have the pairs of points test, and now we have the vertical line test, which uses the graph. And again, we don't have to know how to graph it. John is giving us those pictures. Yay, lesson 87. I'm done. Goodbye.